Okay, so today we're going to talk about dilations. I'm going to pass out this worksheet, cross out the translations word. We already know what a translation is. Remember, a translation is a slide that goes, like if it's going here, and then we're going to go to the right, and then maybe down, and it's that same image, right? That's a translation. And then a reflection would be, say I have a triangle here, we're going to flip it over, and it's going to flip that way, over that, okay? And now we're dealing with something called a dilation. So a dilation is actually, let's go ahead and just actually fill this out a little bit. In math, the word dilate means to enlarge or reduce a figure. And let me just give you an example. If I was to show you a picture on my phone. So here's a picture of my wife, my daughter, my son, and my mother-in-law. That's my wife's mom. And we went to Knott's together. So the reason I was chuckling a little bit is if you could see, you can't really see what's going on with my daughter's face, but you guys all know you can pinch the picture, right? And you can make it bigger, right? So I'm making it bigger. So I'm enlarging the picture. It's still the same picture, but you can see my wife is smiling, my son is smiling, my mother-in-law is smiling. My daughter's not really feeling this ride, all right? But now I've made it bigger, and then I can make it smaller as I keep moving out. All right. So there's an idea of a dilation in your real life. You're making images bigger or smaller. The scale factor, if the scale factor is less than 1, and can you underline the word scale factor? That's going to come into play. If the scale factor is less than 1, your figure gets smaller. If the scale factor is greater than 1, then your figure gets larger. Okay. And you're going to get this really quickly. It's not too difficult. I promise you. And you're like, Marusik, you say that all the time. No, I promise you, it's not that difficult. All right. It's going to say graph the dilated image of triangle JKL using a scale factor of 2. And then it says using 0, 0 as a center of dilation. Don't worry about this last part. This is for like when you're in geometry, your sophomore year, you're going to be going over like what the center of origin is. But you're not doing that in 8th grade. In 8th grade, they just want you to take this triangle and use a scale factor of 2. Now remember, if the scale factor is greater than 1, your figure is going to get larger. Okay? So this number 2 means that this triangle is going to get larger. But let's just take our time right now. And first, we can tell this is the second part, right? This is the pre-image because there's no little apostrophes. There's no primes. But then these guys have these little primes. All right? So let's go ahead and deal with this. J is over 2, up 1, 2, 3, 4. So write out 2, 4. And we're just marking out where the coordinates are, right? K is 1, 1. And then L, hopefully you guys start realizing you are going left or right. This is your X value first, right? Your X value and your Y. So for here, my X is going to the right 4. Am I going up or down? No. So that stays 0. Many students have trouble wondering where the 0 goes on this. Just follow along. You start the origin, you go right 4. You don't go up or down. So 4, 0 makes sense. Now, new image. I'm going to get a new color. So we're going to dilate this triangle by a scale factor of 2. Okay? All that means is multiply everything by 2. That's all it means. Scale factor just means multiply. That's all it means. Multiply all these points by 2. So right here, 2 times 2 is 4. 2 times 4 is 8. Take a second and see what happened there. 2 times 2 is 4. 2 times 4 is 8. And that's all you had to do. Well, this one's super easy, right? 2 times 1, 2 times 1. And then here, 2 times 4, 8. 2 times 0, 0. Okay? So let's go ahead and write these coordinates out. Over 4, up 8, 1, 2, 3, 4, 5, 6, 7, 8. All right, and that's J. K is going to be over 2, up 2. And then L is going to be over 8 and 0. Okay? And draw your triangle. And now, look at these two triangles. They're obviously not the same size. So, not same size, but same shape. Not same size, but same shape. Same shape, but not same size. And what I like to call it, it's like they're almost brothers or sisters or whatever. They're going to be this word. Think about it as little brother and big brother. Little brother, big. They're actually called. Can you please contact the office? Riley, please contact the office. Sorry about that. Now these are actually called similar. These two triangles are similar triangles. They're not identical, but they're similar. Just like your sister or your brothers, whatever you have, you guys are similar. You could tell you maybe look alike a little bit. You're similar, but you're not the same exact shape or size. Same shape, but not size. Okay? Cool, cool, cool. You guys try this one out on your own. Just multiply everything by 3. All right, filling these out for me. Check with your partner, and then go ahead and just multiply everything by 3 and plot that. All right, push pause, Miss Alonzo. Go ahead and work with them on this one. Not too tough. Just multiply every coordinate by 3. Flip it over. Now it gets a little bit different. So this one, you're going to use your calculator. If you want to open up your computer, get your calculator out. And you're going to multiply everything by 1.5. Okay? Use your calculator and multiply everything by 1.5. You guys can do this. Write out your coordinates, multiply them all by 1.5 using your calculator. And then I'm also going to do the same. I'm going to pull up my calculator real quick, and we're going to do the next one because that's where it gets a little bit different. All right. I'm just going to use this one real quick. And I have this here on the side, and I want you to see what I'm going to be doing with this guy. Okay. Because now it's a little different, isn't it? So I'm pretty sure I can do this one if I did like 1 times 3 equals, and then multiply that by 6. Is that going to work for me? All right, so actually, I'm going to pause this. I'm going to get out the real calculator. I realize that this is going to be a little bit of an issue. So take a look at what I have here. We're going to be doing the real calculator here. I want you to use this in the same way, like if you were going to be, watch what I'm going to do right now. We're going to go back to our sheet, and I said multiply everything by 1.5. That's still going to get bigger, right? This is still going to be an enlargement because anything greater than 1 gets larger. But now what if something is less than 1? It's going to get smaller. So go ahead and we're going to go down to number 7. All right. It says graph the dilated image of the MN quadrilateral MNOP using a scale factor of 1/3. So again, this idea, you're going to multiply everything by 1/3. Okay. So now let's do this. Let's actually write out the coordinates first. Over 3 up 1, 2. That's 3, 9. N is going to be 6, 0. O is going to be over 3, down 1, down 2, down 3, down 4, down 5, down 6. All right. And then this is going to be -3, 0. Okay. Now have this paper in front of you. We're going to multiply all of these by 1/3. And I want you to see how easy this is with your calculator. And make sure you're using the Desmos calculator. Okay. So first one we're going to do 1/3. And then I have to click it on the side here. Notice that cursor was down here before. If I just hit the arrow to the side, it also moves that there. Times, we're going to do 3, right? 1/3 times 3, which that equals 1. So write that down on your paper. And then I'm just going to go backspace and go 1/3 times 9. And that equals 3. Okay? So then my coordinate here is 1, 3. Keep doing that. Keep going through there, okay? Do all of these. So if you do 1/3 times 6, you get 2. And you keep on going on your own. Check your work in a second. Make sure you put negatives in there as well. And push pause right now. Check your work. And then I'll show you the answers right now. So here would be your answers, okay? Go ahead and plot these out for me. You're going to see it's going to be over 1, 3, over 2, 0, over 1, down 2, and then -1, 0. And it's the same kind of shape, but it's gotten smaller, okay? Now, you guys can go ahead and try this one. you're going to try to figure out what happened between M and M prime. And this one's kind of tough. But M was 3, 3. And now M prime is 1, 1. So it went bigger to smaller. So you know it's going to be like a fraction, right? It's going to be less than 1. And I'll give you a clue right now. Notice what we did here. We went 3 to 1, right? 3 to 1 here. So it's the same thing. This is a 1/3. Okay? Now, I want you guys to get into my Desmos slide deck. It's not too tough. Don't whine and complain. I know you hear Desmos and some of my students start crying and complaining because I think it was more about doing the equations and having to write all this stuff out. It's not the same way. So make sure you're in the Desmos slide deck. We're going to go through this pretty quick. What do you notice about these two triangles? What's the same? What's different? Okay. Now these triangles, you could talk about what's same, what's different. They're obviously not the same size. So you can write that out. You can definitely write that as an observation. Okay. Go ahead and push pause. Now, these are the same shape, right? But not the same size. These are considered similar triangles, right? Not identical, not the same shape, not same size. All right, we've covered that quite a bit. All right, next slide. This one's kind of cool. They use the letter K to show the scale factor of how it's going to change. Remember, your sheet talked about scale factor. And when I have it here, you can move this around to see it's getting bigger as the scale factor gets bigger. And then as I get smaller, ooh, look at, as I'm at 1, where's the shape? It's on the actual triangle. It's the same size, right? Because if you multiply anything by 1, it's going to stay the same. But when you multiply it by a decimal, less than 1, it's going to get smaller, right? But when you multiply bigger, it's going to get bigger. That's all I wanted you to see. Kind of cool. All right. And they said, how about moving these? What happens if you move, oh, this guy right here. Notice the shape stays the same, but the size is obviously different. Okay. Notice my visual here. I was trying to get real fancy with this slide. Take a second, take a look at it. It's getting bigger. You're getting the idea of this, right? What do you notice as K increases? Answer in the chat. Obviously, this is when I was in Zoom that I used this one, so there's no chat available. You guys can just tell each other. All right, let's see about this video. I think we're going to skip this one. Okay, so you're going to see this happen in a second. Watch that video to get a sense of what's happening, and then I'm actually going to give you, what do you notice about these patterns? What's happening between these coordinates, all right? Talk with your class, see if you can give me an answer for this one. E and E prime, what do you notice happening? All right, this is good to notice the pattern. Math is all about noticing the patterns that are happening. All right, next slide. Go ahead and fill this out. We kind of already did this one. Don't cheat. Try to do this one on your own. And actually, these are actually going to be called, oh, it just wants you to write down the regular coordinates. Don't worry so much about this page. This is the next one. I want you guys to write out the new coordinates. So these are the coordinates. Can you write out the new ones? All right, with a scale factor of 2. All right, now draw a new triangle after dilation. Here is the triangle. Draw the new one with these coordinates. Take your time. I know I'm going through this fast to try to get through the video. All right, dilate the image by 1/2. Use your calculator. Remember your calculator? Okay, use that. And great. Okay, cool. Now go ahead and look at this and tell me if it's a reduction or enlargement and try to explain this. All right, great job. Now I want you guys to get into this booklet. You're going to be doing this booklet together. I'm actually going to have you guys do the booklet. I may have Miss Alonzo do it as a Kahoot style first, and then we'll talk about it, and then she'll give it to you as a normal one. Okay? So do the best you can with this one, and you guys have a great day. Hopefully this is helpful.